On March 8, 1965, under orders from President Lyndon Johnson, nearly 3,500 ground troops stormed the beaches near Da Nang, South Vietnam. By year's end, nearly 200,000 American soldiers are sent across the Pacific in order to stop the dominoes from falling.
We insist, and we will always insist, that the people of South Vietnam shall have the right of choice, the right to shape their own destiny in free elections in the South or throughout all Vietnam under international supervision. And they shall not have any government imposed upon them by force and terror.
With this escalation, supported by both General William Westmoreland and the White House, air power becomes a necessity in the fight against an invisible force. Operating in the remote jungles of Southeast Asia, the Viet Kong wages a guerrilla war against the United States, hoping to drive them south and eventually off Vietnamese soil for good. To combat this threat, a plane, originally built to drop the atomic bomb on the Soviet Union, is called up to fight a conventional war against an unconventional enemy. The B-52 Stratofortress, an aircraft epitomizing America's military strength, begins a campaign lasting nearly 8 years, attacking the enemy from the sky. It is a controversial plan pitting the politicians against the generals, with each side believing they know how to win this war.
General Westmoreland and Admiral Sharp and the Joint Chiefs have, over a period of weeks past, recommended strikes in North Vietnam using B-52s. State has been opposed to this, I think for very good reasons, fearing that it would interfere with the relationships between the government of Vietnam and the ICC, and State has consistently strongly recommended against approval of these strikes.
The United States was run by a bunch of arrogant, aristocratic, Ivy League fools who thought that their psychology was superior to the North Vietnamese psychology, and that they could teach to the Vietnamese how to run a war.
From the mountains of Khe Sanh to the destruction of Hanoi, the B-52 emerges as America's frontline plane, dropping over 3 million tons of bombs against communist North Vietnam. Today, almost 60 years after its first flight, B-52s continue to serve the needs of the United States Air Force. Known to pilots as the Buff, its reputation as one of America's greatest bombers is well deserved, being used in Operation Desert Storm and during Operation Enduring Freedom in Afghanistan. It is hard to imagine that an aircraft designed to meet the needs of the Cold War has maintained its longevity well into the 21st century.
At Castle Air Force Base, California, the B-52, America's biggest and newest jet bomber, goes into squadron service with the Strategic Air Command. A wingspan of 185 feet, length of over 150 feet and intercontinental range, over 6,000 miles without refueling, combat ceiling of 50,000 feet and a speed estimated at over 600 miles an hour. That's the B-52, shown in these Defense Department films going into active service in quantity, threatening devastating counterattack to any aggressor, the mightiest bomber in history.
In 1955, the B-52 begins a career that will last for almost 8 decades. After shocking the Western world with their MiG-15 swept-wing fighter, the United States learns an important lesson: never underestimate the strength and ingenuity of the Soviet Union. In the aftermath of Korea, America is convinced that a new, jet-powered, long-range, intercontinental bomber is vital in dealing with the threat posed by Moscow. With the existing B-36 Peacemakers already obsolete and the B-47 Stratojet experiencing numerous technical problems, This gap in the Strategic Air Command's nuclear deterrent force is what gives life to the B-52.
The B-52 was designed for one purpose only, and that was to carry nuclear weapons in an attack on the Soviet Union in a world war. It was not considered when the aircraft was being designed that it would ever carry conventional bombs. It was not considered when the aircraft was being designed that it would ever fight in Vietnam or in Operation Desert Storm or in the wars that we're fighting today.
At first, the Stratofortress is designed as a propeller-driven aircraft, but as jets proved to be significantly faster, the engineers at Boeing switched to this new form of propulsion. By the end of testing and development, the plane is built with a wingspan of 185 feet, a 45,000-foot ceiling, and a range of over 7,000 miles. Entering service, the aircraft is equipped with 8 jet engines and a top speed of over 500 miles per hour, symbolizing American war strategy by bringing the fight directly to the enemy's homeland. Like the B-17 over Germany and the B-29 over Japan, Boeing's new heavy bomber will hopefully rule over the Soviets. But from the second this plane is introduced, modifications and changes are requested by Strategic Air Command to meet this growing threat. In order to combat Soviet missile defense, the plane must fly in all-weather scenarios, be able to go as low as 500 feet, and carry on board nuclear missiles. During this period, the Stratofortress is involved in some of the most famous and infamous episodes in Cold War history. 1956. A B-52B drops the first ever hydrogen bomb on Bikini Atoll during a series of nuclear tests. Next is its role in propelling the rocket-powered X-15 into the fringes of outer space, achieving a world record of Mach 6.
The X-15 is cut loose 7 miles over the Mojave Desert to fall free and glide back to Earth, testing the stability of the most radically different aerodynamic structure ever engineered. A craft designed to reach speeds of up to 4,000 miles an hour.
Then comes the Cuban Missile Crisis, where America and the entire world are on the edge of their seats, fearful that nuclear Armageddon is just around the corner.
Is now in preparation on that imprisoned island. The purpose of these bases can be none other than to provide a nuclear strike capability against the Western Hemisphere.
During this standoff, 70 B-52s are ordered airborne at all times, waiting for the call to strike. For a plane that proves essential, it is hard to imagine that it almost never saw the light of day. After the debut of the costly B-47, many in Washington wanted to slash the military's budget with the B-52 in the crosshairs. Fortunately, Curtis LeMay fights successfully to keep this bomber alive, knowing these planes will prove invaluable in the next conflict America faces.
Today, the Chinese Reds have succeeded in splitting Vietnam in two and have established a communist puppet government in the north. China's massive and still growing strength is felt throughout Asia.
From the jungles of Southeast Asia, an American meat grinder known as Vietnam would emerge. Following the defeat at Dien Bien Phu, what was known as French Indochina is divided at the 17th parallel into 2 separate nations. Almost immediately after this decision, the Communist North, aligned with Moscow and Peking, stops at nothing to control its neighbor to the south, a strategic American ally. And unlike Korea, where 2 opposing armies battled it out in uniform, this war is fought against an invisible enemy. Guerrilla forces aligned with Hanoi, known as the Viet Kong, conduct a campaign of ambush and sabotage, hoping to destroy Saigon from within. This threat causes the United States to send tens of thousands of advisors to prop up the unpopular government of Ngo Dinh Diem and to train a weak South Vietnamese army for fear of what is called the domino theory.
The domino theory was a current political theory at the time, first promulgated, I believe, by Eisenhower. It was the idea that if one of the countries that were allied, or at least not actively part of the communist sector in Southeast Asia, became communist, that inevitably others would fall. So if North Vietnam made South Vietnam communist, they expected then Cambodia to go, Laos to go, Thailand to go. They expected perhaps, if you played it out to the end, why it would have had some effect in India.
So help you God.
So help me God.
1965. After Lyndon Johnson defeats Senator Barry Goldwater in a landslide, the conflict in Vietnam, escalating during both the Eisenhower and Kennedy administrations, takes center stage.
Renewed hostile actions against United States ships on the high seas in the Gulf of Tonkin.
In a decision that comes back to haunt him, LBJ, almost 1 year after the controversial Gulf of Tonkin incident, authorizes the use of ground troops to maintain stability in the South and to stop a menacing Viet Kong from uniting the two countries under a communist banner. Referring to North Vietnam as a raggedy-ass fourth-rate country, the President and his most trusted advisor, Secretary of Defense Robert McNamara, are convinced the conflict can be won both quickly and successfully. What they are afraid of is letting the military have too much control, as the President is overheard saying that all these generals want to do is bomb, bomb, bomb.
All of my military people tell me, and my economic people, that we cannot do this to the extent of the commitment we have now. It's got to be materially increased. Our 75,000 men are going to be in great danger unless they have 75,000 more. My judgment is, and I'm no military man at all, but I study it every day and every night, and I read the cables. I look back over what's happened in the last 2 years, or the last 4 really, and if they get 150, they'll have to have another 150, and then they'll have to have another 150.
Fearing the ghost of Korea and Douglas MacArthur will come back to haunt this administration, a new directive is issued to Saigon, stating that all bombing missions must be approved by the White House prior to takeoff. As Lyndon Johnson would boast, they can't even hit an outhouse without my approval. The plan proposed by LeMay, calling for 94 targets to be hit over a period of 16 days, is scrapped. Instead, the operation known as Rolling Thunder is put into effect.
The idea was that we would apply pressure to a certain degree, to a certain parallel of latitude, and apply our air power there very effectively. And this would convince the enemy that they obviously couldn't win, they could never match us in our air power, and so that they would surrender.
Targets are not selected by the military brass, but instead by Johnson, McNamara, McGeorge Bundy, and Dean Rusk, who have the final say over what gets bombed. American military leaders are infuriated when Hanoi and a 60-kilometer radius surrounding it is ordered off limits. An attack on North Vietnam's capital could result in an escalation, something President Johnson fears will jeopardize his domestic agenda at home. Likewise, the port of Hai Phong, an important choke point for North Vietnamese shipping, is also immune from attack.
I have stayed away from their industrial targets and their civilian population, although they urge you to do it.
Yeah, but Hanoi and Hai Phong are stripped clean and have been for months. And you bomb them, you get nothing. You just build up more hatred. You get these people tied more closely together because they are tied by blood, whether from the north or the south.
I think that's true, and I think you've done nearly everything that you can do except make it a complete white man's war.
Targets like Hanoi and Hai Phong were deliberately placed off limits by our clever people in Washington who didn't want to offend the Chinese or the Russians, and vastly overestimated what their reaction would have been. And so where we could have just obliterated the harbor at Haiphong and sunk everything that came in. We chose instead to try and stop the guy carrying 100 pounds of rice on the Ho Chi Minh Trail. The war was just done in an Alice in Wonderland style.
It is a controversial strategy intent on keeping vital targets hostage by attacking trivial ones, hoping communist leaders settle for peace before it becomes too late.
We seek no wider war.
The brainchild of McNamara, who plans on micromanaging the war the same way he ran the Ford Motor Company, Rolling Thunder proves to be a total disaster.
What happened was we'd apply a little air power, and then we'd have a bombing halt. They would pull themselves together, reinforce, resupply, and go right on fighting as if nothing had happened to them. And we'd extend our Rolling Thunder a little bit, and the same thing would happen.
Fighting a guerrilla war against an enemy who wears no uniform, the restraints placed on both the Navy and Air Force right from the start makes their mission even more difficult to accomplish. It is in this atmosphere that the B-52 is called up for service. Many are hoping that the Stratofortress can fill the void left by its sister plane, the F-105 Thunderchief, unofficially known as the Thud. Designated a fighter, it is instead a supersonic nuclear bomber built to travel into the Soviet Union on a one-way trip. Weighing as much as the B-17, the decision to incorporate short, stubby wings to increase speed and reduce drag makes the aircraft extremely difficult to fly.
The F-105 fighter was designed by Republic as a nuclear bomber. This was a time when Tactical Air Command was demanding that it have a nuclear capability so it wouldn't be completely overshadowed by SAC. And the F-105 was designed to have an internal bomb bay for a nuclear weapon, and was a very fast airplane, and had a very troubled career originally, its development career, a lot of crashes. Ultimately, it was made into a relatively safe airplane, but then it was flown on a mission entirely foreign to its design. Had to carry external weapons, which of course cut down on its speed.
Unreliable at best. By the time it is replaced, over 400 are lost over Vietnam, more than half the total number built. Arriving in the Pacific, many are skeptical about the B-52's effectiveness against Viet Kong forces, hiding in canopied jungles. Can this aircraft, originally built to drop thermonuclear bombs on Moscow, successfully knock out strategic supply routes and hidden bases? Swatting flies with a sledgehammer is what one Air Force leader calls it.
The B-52 was called in because it was available, just like everything else in the inventory. And the B-52 was applied against concentrations, or supposed concentrations, of the Viet Cong soldiers. And it was useful because it could carry such a great load. They were modified with the B-52s with what they called the big belly modification, so they could carry up to 85 500-pound bombs. And you put 3 of those out every 3 hours over enemy territory, you can create a lot of damage.
The B-52 force remained under the command of the Strategic Air Command, SAC, throughout the entire Vietnam era. And although B-52s operated from Okinawa and Guam and Utapao, Thailand, to bomb targets in Vietnam, they were never under the control of the local commander in Vietnam. They were always part of SAC.
And on June 18, 1965, the first bombers take off from Andersen Air Base in Guam. Their mission is to destroy suspected Viet Cong bases north of Saigon. By the end of the year, many, including General Westmoreland, view the B-52 as indispensable. Marine divisions are delighted by the scope, scale, and accuracy of the plane, providing them with close support during search and destroy operations. It is said that the Viet Cong's worst nightmare is the Stratofortress, that by 1966 is dropping 8,000 tons of bombs per month.
We have got 30 B-52s that have just unloaded their bombs on square mile in South Vietnam, under which we think
very likelihood a concentration of Viet Cong has been giving us all this trouble. And
South Vietnam.
yeah, South Vietnam. It's an area that's got 15, 20 buildings underneath a lot of this bee brush and this heavy stuff covering it. And they've got the caves and every other damn thing. So no plane we got could do it except our B-52, so we brought them in from Okinawa.
Had it switched roles with the F-105, which primarily attacks targets in the north, its devastation could have been even greater.
It was as if everything was being done totally backwards. You had the B-52, which had never been intended to carry conventional bombs at all, but had now proven that it could do so, and it was carrying bombs against a bunch of guys in black pajamas who were running around in the jungle, while F-105s and F-4s were bombing targets in North Vietnam. It seemed to everyone that it was backwards, and it may have seemed to some B-52 crew members that they were not being used properly.
Unfortunately, the restraints placed on the aircraft limit its full potential. Because some North Vietnamese airfields, a key strategic target, are inside the buffer zone with China, B-52s are forbidden to attack them. When General Westmoreland begs for planes to bomb the Viet Cong supply route, known as the Ho Chi Minh Trail, by entering Laos and Cambodia, President Johnson tells him no, fearing it will escalate the conflict even further. The same goes with new surface-to-air missiles, or SAM sites, built to shoot down American aircraft. Since they are constructed near city centers, they too are off limits.
It was so bad that you could watch a SAM battery being built, you could watch it being activated, you could watch it being tested, you could watch them turn it on, but you could not attack it until they locked onto you. I mean, this is so stupid that it just defies imagination. As happened too often, we lost an airplane. You lost two brave guys who are well trained in a $6 or $7 million airplane. I mean, it was just the stupidity of it just rankles, because the pilots knew better, the guys on the ground knew better, the military leaders knew better, and they were unable to offset this dreadful influence from the White House.
People who were planning the missions, in military talk, they were fragging the missions, meaning that they were planning them, were sending these bombers to the same place at the same time on the same heading every day, and these crews knew that the North Vietnamese were ready. One B-52 crew member told me about a North Vietnamese anti-aircraft gunner looking at his watch and saying, "Oh, I'll go back to drinking my tea because the Americans won't be here for another 7 minutes." And by the way, when the Americans do get here 7 minutes from now, they're going to be on a heading of 280 degrees at 32,000 feet.
With American deaths escalating and nearly 500,000 soldiers deployed, the quick war Johnson and McNamara envisioned instead turns into a bloody war of attrition. Westmoreland, a pillar of the Army establishment, intent on fighting large World War II scale battles, is watching his troops get slaughtered. Viet Cong forces avoid these out in the open search and destroy tactics by ambushing their enemy on the ground. Although America never officially loses a battle, the high casualty rates they endure causes support for the war to decline drastically back home. As protests grow in strength, Vietnam appears to be a quagmire. As 1968 begins, B-52s prove vital in the battle at Khe Sanh, what Ho Chi Minh hopes is America's Dien Bien Phu. With U.S. troops outnumbered by a ratio of 5-1, the heavy bomber is sent to provide backup, flying nearly 2,700 sorties and dropping over 75,000 tons of munitions during Operation Niagara. In the end, America emerges victorious at Khe Sanh, with General Westmoreland noting that the thing that broke their back basically was the fire of the B-52s. The victory is overshadowed, however, by massive Viet Cong attacks against South Vietnamese cities during the Tet Offensive. Although the United States pushes these guerrillas back, killing nearly 45,000 and severely weakening their future capabilities, images of the American embassy in Saigon being shot at stuns the entire nation, who had been promised for months that there was light at the end of the tunnel.
We had a press in the country that identified the Tet Offensive as being a great Vietnamese success. In actual fact, we obliterated the Viet Cong in that series of battles and defeated the North Vietnamese army. They were wrecked. They were ready to surrender, and yet they knew they could beat us.
Bombing halts have no effect, giving the enemy time to rearm. The original targets proposed by LeMay are hit, and yet North Vietnam continues to fight. Rolling Thunder is unable to achieve any of its objectives. With protests growing, McNamara resigning, and Lyndon Johnson almost defeated in the New Hampshire primary by anti-war Senator Eugene McCarthy, the president speaks to the nation in a televised address.
I shall not seek, and I will not accept, the nomination of my party for another term as your president.
With Johnson out of the race, the former Vice President Richard Nixon goes on to win the presidential election of 1968. His victory would mean big changes in the air war against North Vietnam and big changes for the B-52.
We will not let down our friends and allies around the world.
As the new president begins his first days in office, a policy known as Vietnamization goes into effect, slowly drawing down U.S. forces by strengthening Saigon's armies. With Nixon as commander-in-chief, the same old tactics are put under intense scrutiny.
I don't want to see another report with 16 sorties by B-52s. I want the enemy to know that we're really letting them have it. So get them in there now. We've got to have it for psychological reasons. We can't have this what appears to be a pusillanimous effort.
While this takes place, the president authorizes airstrikes against the nation of Cambodia, a longtime Viet Cong haven, immune from attack during the Johnson administration. Under Operation Menu, almost 4,000 B-52 sorties drop over 100,000 tons of bombs on suspected sanctuaries, significantly reducing the threat against South Vietnam.
1972, the North Vietnamese knew that the war in Vietnam had become so unpopular in the United States that the U.S. would search for some way to withdraw and that it would have relatively few conditions.
With the bulk of American troops now being sent home, 125,000 North Vietnamese soldiers begin their long-awaited push south on March 30th, 1972, hoping to finally end this war once and for all.
We had gone from 560,000 troops down to about 26,000 troops. And the North Vietnamese responded by sending their regular army in a huge offensive into South Vietnam.
They are instead stopped by massive B-52 firepower, killing over 50,000 enemy troops and destroying over 400 tanks. Switching from a guerrilla campaign to a traditional war play right into the hands of the United States and, more importantly, American air power. They are assisted by South Vietnamese forces putting a halt to the Easter Offensive, with General Adams being quoted as saying, "By God, the South Vietnamese can hack it." And as Nixon and his top foreign policy advisor, Henry Kissinger, engage in a policy of détente with the Red Chinese, North Vietnam begins to feel the pressure from their allies to negotiate. But when communists continue to violate their commitment to peace at the end of 1972, the president orders for the gloves to come off. Dating back to the Johnson era, bombing halts are interpreted by the Americans as an act of kindness, while interpreted by the North as a sign of weakness. By December, though, President Nixon, after being re-elected in one of the biggest landslides in American history, orders the execution of Operation Linebacker II. This plan, to be conducted at the height of monsoon season, calls for the massive bombardment of Hanoi, Haiphong, power plants, rail yards, airfields, and SAM sites in one giant air campaign. F-4s, F-105s, and most importantly, B-52s are instructed to take out these key installations now that North Vietnam is in a vulnerable state. And on December 18, 1972, the first wave of planes takes off, unleashing fury from the air.
729 sorties were made. First sortie, we lost airplanes. Second sortie, we lost airplanes, as I recall. Third sortie, we didn't. But the losses were high, and our tactics were not good. By the third one or fourth one, we improved the tactics. And by that time, we had the other elements assisting the B-52s. We had Navy aircraft and Air Force aircraft beating up their airfields, taking out their SAM defenses. And within days, the North Vietnamese had exhausted their supplies. They couldn't resupply their SAMs, and we had them at our mercy. So we bombed them, had a Christmas recess, which was totally stupid, allowed them to recoup a little bit, but went right back. And lo and behold, the North Vietnamese, who had refused to negotiate, asked if they wouldn't like to go back to Paris and renegotiate.
North Vietnam, in a state of shock and weakness, returns to the negotiating table, and in 1973, a ceasefire is reached, ending the war after more than 7 years. However, with no American presence in South Vietnam, by 1975, the Communists are successful in uniting the two countries, marking a great defeat for the United States. Looking back at the air campaign in Vietnam, the B-52, as General Westmoreland said, proved indispensable. Its role in providing air support for troops on the ground, most notably during Khe Sanh and later in obliterating strategic targets in the north, completely changed the war. Had the Stratofortress not been used, the outcome could have been very different, possibly leading to an earlier American defeat. However, a series of rules imposed on the plane by Washington, D.C. turned out to be the B-52's biggest detriment. Targets that should have been hit from day one were left out, allowing North Vietnam to continue their proxy war in the south through the Viet Kong. Had these restraints been lifted and a 100% effort been given in 1965, the B-52, along with the entire Vietnam War, could have ended in a stalemate instead of a total communist victory.
The F-100 is one of our primary tactical support weapons systems. This aircraft has a proven history of outstanding performance. One of the reasons for this dependability is the rugged power plant. The One, a high-performance aircraft, is adaptable to many missions. It is used for reconnaissance, as a tactical fighter, and as an interceptor. Approximately 30,000 pounds of thrust is developed by its twin engine. The F-102 is the first operational Air Force Delta Wing aircraft. The performance characteristics of this weapon system are ideally suited for intercept missions. A reliable power plant is essential for the success of any mission. The F-102, 101, and 100 are all powered by the rugged J-57 engine developed by Pratt & Whitney. The individual engines vary somewhat, but for the most part are the same fundamental design. The J-57 is a dual compressor engine. The engine consists of the following components: the inlet, the low-pressure compressor, the high-pressure compressor, the diffuser case, combustion chamber, the first, second, and third stage turbines, the afterburner, and the exhaust nozzle. The low-pressure compressor, referred to as N1, is driven by the second and third stage turbines. The high-pressure compressor, N2, is driven by the first stage turbine. These two units, or spools, are not mechanically connected. The J-57 operates on the same basic principle as all jet engines. Pressure, presented in graph form below the basic engine outline, and velocity are increased by a series of rotors in the compressor section. A compressor bleed system prevents compressor instability when the engine is operating at reduced power. The compressed air passes through the diffuser into the combustion chamber, where the air expands, thus reducing somewhat the velocity and pressure. Fuel is mixed with a portion of the air to form the combustible mass. When combustion occurs, the gases are expelled through the turbines. At this point, power is extracted by the turbines to drive the compressors. The remaining energy, expelled through the exhaust nozzle, provides the thrust. Since exhaust nozzle and turbine discharge pressures are relative, turbine discharge pressure is used as a parameter to determine thrust. Thrust is the measure of force developed by the engine. Force is determined by mass times acceleration. Mass is the weight of air and fuel passing through the engine. Acceleration is the difference between inlet and turbine discharge velocities of this mass. Thus, thrust may be expressed by the formula force equals mass times acceleration. The engine trim charts are based on this formula. Additional thrust is obtained in the afterburner by increasing mass and acceleration at that stage. The basic engine pressure ratio during afterburner operation is maintained by increasing the exhaust nozzle area. Efficient engine operation depends on correct fuel schedule. The basic components of the J-57 main engine fuel system are fuel pump and fuel pump transfer valve, fuel control, and the pressurizing and dump valve. The fuel pump is a dual-element spur gear pump. One element supplies fuel to the afterburner, the other to the main engine. The fuel control meters the fuel required to operate the engine through its full range. The pressurizing and dump valve supplies the main engine fuel manifold and drains the manifold at engine shutdown. At engine start, fuel enters the pump through the impeller where the pressure is increased. This provides a positive pressure head to the main stage. At this stage, the fuel reaches output pressure. The pressurized fuel closes the fuel regulating transfer valve and the afterburner check valve and flows into the fuel control. The main metering valve is closed at this time. A portion of this fuel passes through the minimum flow orifice through the signal line to the P&D valve. Since the control is in bypass, pressure does not build up enough to close this valve until the power lever moves from cutoff to idle. When the power lever is moved to the idle position, the fuel dump valve closes. The main metering valve opens. The cutoff valve moves off its seat. The pressure loading valve opens. The P&D valve inlet check valve opens. And fuel is supplied to the primary side of the fuel manifold through the pressurizing and dump valve. At approximately 74% RPM, the fuel pressurizing valve will open to supply fuel to the secondary side of the fuel manifold. The J-57 engine uses a primary and secondary system in order to obtain the highest possible fuel flow with the shortest possible flame. At low RPMs, only the primary side is used. When the emergency system is selected, the actuator positions the pilot valve to direct pressure to the shuttle valve system. The shuttle valve blocks off metered flow and provides a port for unmetered fuel to the emergency throttle valve. This mechanical valve controls the flow of fuel. The afterburner element of the fuel pump will supply fuel to the engine in the event of main element failure. The primary function is to furnish fuel for the afterburner. The other components of the J-57 afterburner system are the afterburner fuel control, exhaust nozzle control, igniter valve, and the mechanical shutoff valve. The relative position of the components varies according to engine model. The afterburner fuel control meters fuel to the AB spray box. The exhaust nozzle control directs compressor discharge air to open and close the nozzles. The igniter valve injects fuel into the combustion chamber, creating a streak of flame to ignite the afterburner. In the event of electrical failure, the mechanical shutoff valve will terminate AB operation at approximately 80% RPM. Rotation of this valve causes AB stage fuel to bypass through the AB fuel control regulator valve. The fuel control unit is carefully calibrated on the test bench to assure accurate engine fuel schedule. The main functions of the fuel control are to maintain acceleration schedules below compressor stall zone, to prevent over-temperature during acceleration, prevent lean die-out during deceleration, and to maintain any selected engine speed within operating limits, regardless of altitude. The fuel control senses engine RPM, inlet temperature, and burner pressure to supply the correct amount of fuel for any ambient condition. When calibration has been completed, all external adjustments, except the idle and military trim screws, are sealed. These seals are installed to protect test bench precision calibrations and must not be removed. The J-57 engine will provide relatively trouble-free operation when all systems are functioning correctly. However, the systems must be properly rigged and adjusted. One of the most critical engine adjustments is the rigging of the fuel control linkage. Full range movement is obtained only when the fuel control and afterburner mechanical shutoff valve levers are correctly positioned. The levers are set to predetermined angles. A protractor or etched template is used to set the linkage at these angles. The protractor is positioned at the oil pump and accessory housing plug to establish a reference angle. This reference angle will be used to adjust the fuel control lever. With the fuel control lever in cutoff position, the difference between the reference angle and this reading must be the number of degrees specified in the tech manual. It may be necessary to readjust the fuel control lever to obtain the correct angle. The fuel control lever and serrated spacer are ratcheted to give the desired angle. The fuel control position, which, when all other linkage is connected, will close the afterburner mechanical shutoff valve. The power actuating rod is then attached to the fuel control lever. Move the mechanical shutoff lever to the detent position. The rod, connecting the cross shaft lever and mechanical shutoff valve lever, may have to be adjusted to the specified length. The AB mechanical shutoff valve is held in detent position, while the lever is ratcheted to the position where the rod, which has already been adjusted to the specified length, will fit. Then all connections are tightened. Either the protractor or an etched template is used to again check the angle of the fuel control lever. It may be necessary to readjust the fuel control lever to obtain the correct angle. After corrections are made, all connections are then safety. Replacement or adjustment of most components will affect engine operation. Prior to aircraft installation, the engine is thoroughly inspected and tested to ensure satisfactory performance. A fuel leak check is imperative before initial start of a repaired engine. With the system pressurized, check all fuel lines and connections. The exhaust nozzle opening must also be rechecked before initial engine start. Nozzle diameter not within specified limits will affect engine efficiency. On some engines, a fail-safe device is installed to prevent total loss of power in the event of linkage failure. The device will position the fuel control lever to a 45-degree angle setting, which will provide approximately 90% RPM, thus ensuring sufficient thrust to maintain flight. After installation in the aircraft, all airframe to engine connections must be checked and adjusted, and the engine retrimmed. Final trim, to compensate for aircraft installation losses, is preferably accomplished with the aircraft headed directly into the wind. Prevailing wind velocity and direction must be within limits specified in the tech manual. The trim pad area must be free of loose objects that could damage the engine if ingested. To effectively trim the engine, power control settings must be coordinated. Throttle linkage is operationally tested before making fuel control adjustments. Movement of the fuel control quadrant must synchronize with throttle movement. Power control movement is transferred to obtain predetermined fuel control settings. The aircraft manual indicates the relative degree of movement throughout the entire throttle range. Close attention to detail is required when trimming an engine. Changes in ambient barometric pressure and temperature will affect engine performance characteristics. True barometric pressure and correct temperature, both recorded within 15 minutes of the trim run, are used to determine target PP7. Target PP7 is obtained by tracing the temperature and pressure coordinates on the trim chart. Start engine is specified in the tech manual and allow engine and exhaust gas temperature to stabilize. Retard throttle to idle setting. Desired idle speed is obtained by adjusting the idle trim screw. As in all fuel control adjustments, final trim is always in the increased RPM direction. Proceeding with the trim operations, slowly advance throttle to military power. Allow 5 minutes for stabilizing. Caution, do not overspeed or overtemp engine during run-up and stabilization. With throttle set at military power, record RPM, EGT, and the turbine discharge pressure, PP7. If PP7 reading is low, return throttle to idle and readjust maximum RPM setting at the fuel control. Turn the adjustment clockwise to increase RPM in order to obtain target PP7. Advance throttle to military power. stabilize, then recheck PT7. Return throttle to idle. Check EGT and RPM. Make certain that RPM is within 2% of data plate speed indication. At the completion of the trim run, follow standard shutdown procedures. Accurate troubleshooting depends on a thorough understanding of the J-57 engine and its system functions. Only by correct analysis of the interrelated parameters can the malfunction be isolated. Proficient troubleshooting is the mark of quality. The Tech Manual outlines the common symptoms of engine malfunctions, the probable causes, and their remedies. Basic parameters used to determine engine performance must also be considered when analyzing problems. These basic parameters are RPM, PT7, and EGT. One of the most detrimental engine malfunctions is overtemping, or high EGT. Perform static checks of PT7 lines and connections and the exhaust nozzle opening. Make sure the anti-icing valves are closed. Then check for instrument accuracy. All static checks have been performed and found satisfactory. Now the engine must be checked for proper trim. As engine approaches military power, check exhaust nozzle for creep. Check to make sure that PT7 has not exceeded target and RPM is within data plate limits. If high EGT still exists, the engine must be removed and a hot section inspection must be performed. Inspect the burner cans for cracks or hot spots. Check fuel nozzles for loose, burned, or missing air caps, and evidence of seal leaks or clogged air holes. Check the first stage turbine nozzle guide vanes for excessive bow. Turbine vanes bowed beyond limits will distort the gas path, causing loss of turbine efficiency. The amount of fuel required to compensate for this loss accounts for the excess temperature. In conjunction with correction of the bowed nozzle guide vanes, or providing they were within limits, additional checks are necessary to assure the problem is corrected. Inspect first and second stage outer air seals for cracks, burned areas, and damage to outer knife edges. Check clearance between outer air seals and turbine blade shrouds. Check first stage turbine dislocating dimensions. The cause of high EGT may have been one major problem isolated at any phase of the investigation, or the accumulation of minor deficiencies requiring several procedures to isolate and correct. Had RPM exceeded data plate limits during initial high EGT troubleshooting trim run, the engine would have to be field cleaned before proceeding with other checks. This process is intended to restore compressor efficiency. When this operation is completed, retrimming the engine may bring all parameters within limits. When troubleshooting engine performance deficiencies, it is necessary to consider all three parameters: EGT, RPM, and PT7. As an example, failure to obtain target PT7 can be caused by many things. By comparing the relationship to EGT and RPM, many unnecessary troubleshooting steps can be eliminated. For instance, when all three parameters are low, a fuel scheduling deficiency is indicated. First, check for full travel of the power lever at the fuel control quadrant. Military position must not be less than 54 degrees. The next step is to remove the fuel control and check the position of the camshaft. With camshaft cover removed, lever positioned at 11 degrees, and the temperature sense bulb in a 60-degree Fahrenheit bath, measure the distance from the end of camshaft to the cover flange. This reading should coincide with that on the camshaft depth plate. Tolerances and replacement instruction are included in the engine tech manual. The engine tech manual includes specific instructions for maintenance procedures. These manuals represent a vast accumulation of knowledge and experience. Through individual ability, initiative, and constant use of the tech manual, proper maintenance and troubleshooting procedures can be achieved. This is the goal of the Improved Maintenance Program.
If you enjoyed this video, please remember to like and subscribe. And as always, thank you for watching.